Good morning. I am Devasena. In this lecture, we are going to discuss about condition of reciprocity in two-port networks. This topic is present in the subject circuit analysis under the unit two-port networks. Let us discuss about a two-port reciprocal network. If a two-port network satisfies the reciprocity theorem, then it is called a reciprocal network. Reciprocity theorem states that the ratio of excitation to response remains invariant when the position of source and response are interchanged. Let us discuss about the condition of reciprocity. Hence, by reciprocity theorem, we can say that in a reciprocal two-port network, the ratio of excitation at port 1 and the response at port 2 will be the same as the ratio of excitation at port 2 and the response at port 1. In the two-port network, if the forward and reverse transfer impedances are the same, then the network will be a reciprocal network. Also, it can be observed that all passive networks are reciprocal. The transfer impedances can be measured as shown in figure A and figure B. This is the representation of figure A and figure B. In this figure A, we have considered that the voltage at port 1 V1 is equal to Vs, and we have considered that voltage at port 2 is short circuited, that is V2 is equal to 0, and the value of I2 dash is equal to minus I2. This is the information indicated in figure A. Now let's see about figure B. In the figure B, we have considered that the voltage at port 2 V2 is equal to V suffix S, and the voltage at port 1, that is V1, is considered to be 0. That is, we have considered input port as short circuited, and I1 dash is equal to minus I1. This is the information we obtained from figure B. Let us discuss about the condition of reciprocity for Z parameters. The basic equations of Z parameters, also called as impedance parameters, are as follows. V1 is equal to Z11 I1 plus Z12 I2. Consider this as equation 1. That is, voltage at port 1 V1 is the function of the current at port 1, that is I1, and the current at port 2, that is I2. This is indicated in equation 1. That is, V suffix 1 is equal to Z11 I1 plus Z12 I2. Similarly, voltage at port 2 V2 is equal to Z21 I1 plus Z22 I2. This is equation 2. That is, voltage at port 2 is the function of current at port 1, that is I1, and current at port 2, that is I2. That is, V suffix 2 is equal to Z21 I1 plus Z22 I2. This is indicated in equation 2. Consider figure A. This is the representation of figure A. In this figure A, we have considered that port 1, that is voltage at port 1 is equal to V suffix S, and voltage at port 2, that is V2, is short circuited. Because V2 is short circuited, the current I2 dash value is equal to minus I2, because the current I2 is flowing into the network, but we are obtaining the value of current I2 dash. That is why minus sign is indicated here. Hence, equation 1 can be written as, this is the equation 1, that is V suffix 1 is equal to Z11 I1 plus Z12 I2. Here we are going to substitute the value of V1 is equal to Vs, and we are going to substitute the value of I2 as minus I2 dash. So the equation 1 becomes V suffix s is equal to Z11 I1 plus Z12, open the bracket, minus I2 dash, close the bracket. We have considered this as equation 3. Now we are going to discuss about equation 2. For this equation 2, the equation 2 can be written as, this is equation 2, that is V suffix 2 is equal to Z21 I1 plus Z22 I2. Here we are going to substitute the value of V2 is equal to 0 and I2 is equal to minus I2 dash. That is 0 is equal to Z21 I1 plus Z22, open the bracket, minus I2 dash, close the bracket. Therefore, minus Z21 I1 is equal to minus Z22 I2 dash. So, I suffix 1 is equal to Z22 divided by Z21 into I2 dash. We have considered this as equation 4. Substituting the value of I1 from equation 4 in equation 3, we get V suffix s is equal to Z11 into, in place of I1 we have substituted that Z22 divided by Z21 into I2 dash, close the bracket, minus Z12 I2 dash. Therefore, V suffix s is equal to, open the bracket, Z11 Z22 minus Z21 Z12 divided by Z21, close the bracket, into I2 dash. Here we have taken I2 dash as common and we have taken the LCM for these two values. Therefore, V suffix s divided by I2 dash is equal to Z11 Z22 minus Z21 Z12 divided by Z21. We have considered this as equation 5. Now consider figure B. This is the representation of figure B. In this figure B, we have considered that V suffix 2, that is voltage at port 2 is equal to V suffix s, and voltage at port 1 is considered to be short circuited. So the value of V suffix 1 is equal to 0 and I1 dash is equal to minus I1, because the direction of I1 dash and I1 are opposite. Hence, equation 1 can be written as, this is the equation 1, V suffix 1 is equal to Z11 I1 plus Z12 I2. So, if you are going to substitute the values of V2 is equal to Vs, V1 is equal to 0 and I1 dash is equal to minus I1 in equation 1, means the equation 1 becomes 0 is equal to Z11 I1 dash plus Z12 I2, that is Z11 I1 dash is equal to Z12 I2. Therefore, I2 is equal to Z11 by Z12 into I1 dash. I have considered this as equation 6. Hence, equation 2 is written with the help of figure B as the equation 2 is V suffix 2 is equal to Z21 I1 plus Z22 I2. In this equation, we are going to substitute the value of V2 is equal to Vs, V1 is equal to 0 and I1 dash is equal to minus I1. So we get V suffix S is equal to Z21 open the bracket minus I1 dash close the bracket plus I2 into Z22. We have considered this as equation 7. Substituting the value of equation 6 in equation 7, we get V suffix S is equal to minus Z21 I1 dash plus Z22 into open the bracket Z11 divided by Z12 into I1 dash. Therefore, V suffix S is equal to open the bracket Z22 Z11 minus Z12 Z21 the whole divided by Z12 into I1 dash. We have taken I1 dash as common and taken the LCM of the above equation. We get these values. Therefore, V suffix S divided by I1 dash is equal to Z22 Z11 minus Z12 Z21 the whole divided by Z12. We have considered this as equation 8. Condition of reciprocity, V suffix S divided by I1 dash is equal to V suffix S divided by I2 dash. So therefore, from equation 5 and equation 8, we get Z22 Z11 minus Z12 Z21 the whole divided by Z12, that is equal to Z11 Z22 minus Z21 Z12 the whole divided by Z21, that is Z12 is equal to Z21. This is the equation that represents the condition of reciprocity for Z parameters. Now we are going to obtain the equation for the condition of reciprocity for Y parameters, that is admittance parameters. We know that admittance is the ratio of current by voltage. That is, in admittance, the current is considered to be the dependent variable and voltage is considered to be the independent variable. The basic equations of Y parameters are as follows. I1 that is equal to Y11 V1 plus Y12 V2. Consider this as equation 9. That is, input current is the function of input voltage and output voltage. I2 is equal to Y21 V1 plus Y22 V2. Consider this as equation 10. That is, output current I2 is the function of V1 and V2. Consider figure A. This is the representation of figure A. In this figure A, we have considered V1 is equal to Vs, V2 is equal to 0 and I2 dash is equal to minus I2. Hence, equation 9 can be written as, this is our equation 9. The equation 9 is I1 is equal to Y11 V1 plus Y12 V2. In this equation, we are going to substitute V1 is equal to Vs, V2 is equal to 0 and I2 is equal to minus I2 dash. So we get I1 is equal to Y11 Vs. This is considered to be equation 11. Equation 10 can be written with the help of this figure A as, this is our equation 10. The equation 10 is I2 is equal to y21 v1 plus y22 v2. In this equation, we are going to substitute the values of v1 is equal to vs, v2 is equal to 0 and I2 dash is equal to minus I2. So this equation 10 can be written as minus I2 dash is equal to y21 vs. That is, the value of I2 is substituted here and the value of v1 and v2 is substituted here. Therefore, v suffix s divided by I2 dash is equal to minus 1 by y21. I have considered this as equation 12. Now consider figure B. This is figure B. Here, v suffix 2 is equal to vs, v1 is equal to 0. That is, input voltage is short circuited and I1 dash is equal to minus I1 because I1 dash and I1 are in opposite directions. So equation 9 can be written as, this is our equation 9, that is I1 is equal to y11 v1 plus y12 v2. Here we have substituted the values of v2 is equal to vs, v1 is equal to 0 and I1 dash is equal to minus I1 in equation 9. So equation 9 can be written as minus I1 dash is equal to y12 vs. Therefore, vs divided by I1 dash is equal to minus 1 divided by y12. Consider this as equation 13. Network is said to be reciprocal if Vs divided by I1 dash is equal to Vs divided by I2 dash. This is the equation for the condition of reciprocity. So from equation 12 and equation 13 we obtain the values of Vs divided by I1 dash and Vs divided by I2 dash. We are going to substitute these values from equation 12 and equation 2 to the above equation. We get, that is, minus 1 divided by y suffix 12 is equal to minus 1 divided by y21. Therefore, y12 is equal to y21. Y suffix 12 is equal to y suffix t1. This equation represents the condition of reciprocity for y parameters. Let us see the condition of reciprocity for h parameters. The basic equations of h parameters, also called as hybrid parameters, are as follows. This is equation 14, that is v1 is equal to h11 I1 plus h12 v2. That is, input voltage v1 is the function of input current I1 and output voltage v2. This is indicated in equation 14. That is, v1 is equal to h11 I1 plus h12 v2. Then I2 is equal to h21 I1 plus h22 v2. This is equation 15. That is, output current I2 is the function of input current I1 and output voltage v2. This is indicated in equation 15. That is, I2 is equal to h21 I1 plus h22 v2. Consider figure A, and this is our figure A. Here V1 is equal to Vs and V2 is equal to 0. That is, output voltage V2 is considered to be short circuited. Therefore, I2 dash is equal to minus I2 because I2 dash and I2 are flowing in opposite directions. Equation 14 can be written as, this is the equation 14. Equation 14 is V1 is equal to h11 I1 plus h12 V2. Here we are going to substitute, in place of V1 we are going to put Vs. and in place of V2 we are going to put 0. So equation 14 can be Vs is equal to H11I1. Consider this as equation 16. Now equation 15 can be written as, the equation 15 is I2 is equal to H21I1 plus H22V2. Here we are going to put V2 is equal to 0. So equation, and we are going to substitute the value of I2. So equation 15 can be minus I2 dash is equal to H21I1. That is I1 is equal to minus 1 divided by H21 into I2 dash. Consider this as equation 17. Substituting the value of I1 from equation 17 in equation 16, equation 16 becomes V suffix s is equal to H11 into, open the bracket, minus 1 divided by H21 into I2 dash. This is the value of I1 we obtained from equation 17. So if we simplify this equation, means we get Vs divided by I2 dash is equal to minus H11 divided by H21. Consider figure B. This is the representation of figure B. Here we have considered V2 is equal to Vs. V1 is equal to 0. That is, input voltage is considered to be short circuited, and I1 dash is equal to minus I1 because the I1 dash and I1 are flowing in opposite directions. Therefore, equation 14 can be written as, this is the equation 14, V1 is equal to H11 I1 plus H12 V2. Here we are going to substitute the value of V2 as Vs, and we are going to substitute the value of V1 and I1. So equation 14 can be written as 0 is equal to H11 open bracket minus I1 dash plus H12 Vs. Therefore H11 I1 dash is equal to H12 Vs. That is, Vs divided by I1 dash is equal to H11 by H12. Consider this as equation 18. The network is said to be reciprocal if the condition of reciprocity Vs divided by I1 dash is equal to Vs divided by I2 dash has to be satisfied. Therefore, we know the value of Vs divided by I1 dash and we know the value of Vs divided by I2 dash. Let's substitute these values from the above equations. We get H11 divided by H12, that is equal to minus H11 divided by H21. That is, H12 is equal to minus H21. This equation represents the condition of reciprocity for H parameters or hybrid parameters. Let us discuss the condition of reciprocity for transmission parameters, that is ABCD parameters. The basic equations for the transmission parameters, that is ABCD parameters, are as follows. Here V1 is equal to A into V2 plus B into minus I2. Consider this as equation 19. That is, input voltage V1 is a function of output voltage V2 and output current I2. This is indicated in equation 19. And equation 20, that is I1 is equal to CV2 plus D into minus I2. That is, input current I1 is a function of output voltage V2 and output current I2. This is indicated in equation 20. Consider figure A, and this is the representation of figure A. Here we have considered that V1 is equal to Vs, V2 is equal to 0, that is output voltage V2 is short circuited, and I2 dash is equal to minus I2 because I2 dash and I2 are flowing in opposite directions. Therefore, equation 19 can be written as, this is our equation 19, V1 is equal to AV2 plus B into minus I2. We are going to substitute the above values. Therefore, Vs is equal to B into minus I2 dash, because the value of V1 is considered to be Vs and V2 is equal to 0. This is being substituted in equation 19. That is, Vs is equal to B I2 dash. Therefore, B is equal to Vs divided by I2 dash. Consider this as equation 21. Consider figure B. This is the representation of figure B. Here we have considered V2 is equal to Vs, V1 is equal to 0. That is, input voltage V1 is considered to be short circuited and I1 dash is equal to minus I1 because the current I1 dash and I1 are flowing in opposite directions. So equation 19 can be written as, this is our equation 19, V1 is equal to AV2 plus B into minus I2. Here we are going to put the value of V1, V2 and I2, that is 0 is equal to AVS plus B into minus I2. If you simplify means we get 0 is equal to AVS minus B into I2. Consider this as equation 22. Equation 20 can be written as minus I1 dash is equal to CVS plus D of minus I2. That is, minus I1 dash is equal to CVS minus DI2. Consider this is equation 23. From equation 22, we have minus AVS is equal to minus BI2. That is, I2 is equal to A by B into V by S. Consider this as equation 24. Substituting this value of I2 from equation 24 in equation 23, we get minus I1 dash is equal to CVS minus D into A by B into Vs. Here we have substituted the value of I2. Therefore, minus I1 dash is equal to BC minus AD divided by B into Vs. Here we have taken the LCM and we have taken Vs as common. Therefore, Vs divided by I1 dash is equal to capital B divided by BC minus AD. The network is said to be reciprocal if the condition of reciprocity Vs divided by I1 dash is equal to Vs divided by I2 dash has to be satisfied. We are having the value of Vs divided by I1 dash and Vs divided by I2 dash. So substitute these values, we get B divided by AD minus BC, that is equal to B. Therefore, AD minus BC is equal to 1. This is the condition of reciprocity for transmission parameters. Thank you very much for listening to this lecture. For further updates, kindly subscribe this channel. If you like this video means you can share this video with your friends.